So I mean, you can also apply 1 by 9 for all pixels, or you can also apply unequal values, for example. Then in such case, it becomes a weighted filter. Okay, instead of an averaging filter, you can apply a weighted filter. So you can increase the filter I mean values. For example, in this case, we are the filter values here are zeros. Only the center pixel value is 1, all other pixel value is 0. Then what it does is it immediately returns the same value of the pixel into this. Okay, so nothing is altered. So it's basically being a an identity function. So similarly, this is a mean value. Similarly, you can also look at, I told you how the filter sizes will change the what is called the image information. So it's more blur happens as large pixel size. So essentially what happens is that you are taking an image I of u comma v. Yeah, you are in this position. You have the filter h. Now you are taking a point by point operation, your point by point multiplication, and then all of them you are multiplying, and finally you are adding. So you are trying to get the sum value of the pixel here, which is supposed to be called as the filtered output. This is called as a filtered output. This is what is called as a filter. H is a filter. This is the input image. So essentially you're getting a filtered output, something like this. So filtered output is supposed to do certain function, right? Filtered output should have operated on the I and should have brought a new information. So I mean, the idea of doing any filter operation is that we try to get a new information from the original image. So some of the information that are not seen in the original image may be seen in the new image, right? So essentially, this is the reason why you go for weighted smoothing filters or unweighted smoothing filters. And a typical unweighted, so all of them are 1 by uniform, right? In this case, you put higher values, so you emphasize more on one particular pixel value compared to the neighboring pixels. So this is called weighted averaging. So you can do a weighted averaging, something like this. Please remember this 40 is changed because the total value of this is 40. So this basically called as the scaling factor. Okay, these are integer coefficients. So you essentially compute these values over this entire image and then perform. So we have till now we have been seeing something called as the linear filters or smoothing filters. Smoothing filters sometimes this 1 by 1, or for example a 5 by 5 kind of filter that you can take. Okay, and then do this, and then you can also have a Laplacian filter. Please look at the shape of the filter here. Now this is always positive. All values are positive, but it gives importance to the center pixel and gives less importance to the pixels at the end. So tail pixels. So tail pixels, because it's the range, right? So in this range, it gives less importance to this. But however, look at this this thing. It gives negative values to certain pixels that are surrounding to this. So Laplacian filter, because the Laplacian, any negative operation, I tell you, negative filter having a negative coefficient will try to bring sometimes the edge information. So this is generally called as a Gaussian filter, because it has the mean and standard deviation built in. So so we also have this coefficient which is negative. So this is sometimes called as the Laplacian filter. So it gives the sometimes gives the edge information. We'll see that some of them some gradient filters of this type